Sounds good. Thank you, everybody, for coming to our second lecture series in terms of our fall residential series sessions. I'd like to thank our funders and sponsors from Idaho Power. They funded the two residential lecture series of our overall fall lecture series. NIA has sponsored the commercial sessions, the next of which is this Thursday. We'll have Heather Burpee talking about high-performance hospitals and targeting an EUI of 100 and what that takes in the healthcare industry. Thanks for coming tonight. A couple of housekeeping rules. We've got a bathroom all the way down this hall and to the left. You can also go all the way down the hall this way, travel about a quarter mile, and you'll eventually hit a bathroom if you walk in that direction. I'm really pleased to have Skip Leitner here presenting for our second session. If you were here last week, we had Joe Swithenford talking about high-performance envelopes and advanced installation techniques, talking a lot about the design and envelope side of energy efficiency. And Skip will be talking about the human kind of behavioral side with his talk on residential energy management systems and kind of an overview of the topology of that type of technology and what it can offer us in terms of energy efficiency. Thank you for coming. John, some background. Skip, as he likes to be referred to as, is a resource economist with more than 40 years of experience in energy and economic impact studies, public policy analysis, and economic development planning. He has his master's degree in resource economics. He's worked through the mid-2006, all the way back to 1997. He worked as the senior economist for the technology policy with EPA's Office of Atmospheric Programs. And since 2006, he has joined the American Council for an Energy Efficient Economy and has served as a visiting fellow and senior economist. So please help me welcome John to the lab.
Thanks very much, Jake. I couldn't be more delighted to be here. Your invitation gave me a chance to step back and think about how to integrate some more of the technical work I do with perhaps more of the human dimension element, as it may affect the larger well-being of our economy in some surprising ways. So I'm actually going to do a little bit of a melding here. Yes, I'm going to be talking about the people side of sustainability, as we suggest, or we might think of the intersection of behavior, information, and residential energy management systems, all as it may move us to hopefully a higher level of economic performance over time. In this regard, I also want to take a step back and suggest that this might be in the tradition, the spirit and tradition of Nobel laureate Richard Feynman at the University of California, California Institute of Technology. He was a physicist. In 1959, he gave a most remarkable talk called Plenty of Room at the Bottom. He was imagining at that time the ability for us to store the entire Encyclopedia Britannica on the head of a pin, basically, even before Don Eigler, an IBM physicist in 1989, learned how to manipulate cesium atoms to spell the words IBM under a microscope, 30 years ahead of his time. His topic was, again, plenty of room at the bottom. Didn't use a single equation, but he laid the foundation for some of the weird notions we're now beginning to see popping into our discussion of new materials, new designs, new thinking about how things like energy can affect our ability and maintain our well-being. So I really do recommend. I first read his essay 15 years ago, and it's informed a lot of my thinking here today. Just taking a step back, reimagining what it means to bring forward this thing we call the human dimension and our nation's energy system to produce a larger sense of well-being. But then I also have to think back, not just Richard Feynman, but my favorite American philosopher, Gary Larson, who reminds us in one of his cartoons, small difference in assumptions can have a very big difference in outcomes. So we have here a dog in the back seat of his master's car talking to his friend in the front yard saying, "Ha-ha, Biff, guess what? After we go to the drugstore and the vets to the post office, I'm going to the vets to get tutored." Small differences in assumptions can have very big differences in outcome. With apologies to Gary Larson, I'm a desert rat. I reside now in Tucson. I've been actually hiking the Sonoran Desert for many years, and this particular image pops to mind, suggesting that if we do make the entire wrong set of assumptions about our nation's energy system, if we fail to understand what needs to be done about energy in some very critical ways, we may have this. A smart-ass cactus speaking to us quite frankly on behalf of Mother Nature in ways that we might not otherwise imagine. This is an actual cactus about 1.5 miles from my back door. and it reminds me very often the need to take these things very seriously. So with that, the road ahead, opening thoughts and questions we ask, very much in the spirit of Richard Feynman. How big energy efficiency, making energy efficiency visible, hence the role of energy management systems, giving us a sense of how big the behavior resource might be if we thought about behavior producing greater gains in energy efficiency. But then more critically, what we might do to engage people in sustainable and more energy efficient practices. And then finally, not taking up the whole wad of time, lots of questions as well as perhaps a good discussion here. So let me open with a question. Other than population, what might be the single largest contributor to environmental degradation? And I would argue the large scale and inefficient use of energy. And I think the numbers are going to surprise you here. This is based on my work coming off of my research sabbatical the past year with my colleague Bob Ayres, Robert Ayres. Some of you may know Ayres. Bob is a physicist, his first degree, but an economist. He is the godfather of what we call industrial ecology. That is to say, it's not just operating the economy with a little bit of investment, a little bit of labor, but it takes energy and material flows. And building on his work, I've come up with the year 2010 that all the energy that the United States throws at the economic problem, 86% of it is wasted, not used and useful in the way of producing goods and services. Now that magnitude of waste, as you might imagine, imposes a very large array of costs that severely constrains the well-being of our economy. In fact, if we look at the trend of our economy the last 100 years, we've been getting weaker and weaker in terms of growth of what we call GDP. And it can be traced back to this huge array of costs as we consume energy and other resources, water, materials, in the production of goods and services. So the conclusion immediately is the most immediate opportunity to ensure a more robust and sustainable economy is to quadruple or even quintuple, I would argue, our current 14% level of inefficiency, and then leading the way. The first important step is understanding and building up the people side of sustainability. So in fact, we need to redirect our understanding of how the economy is actually working and how this large array of costs imposes constraints on our larger social and economic well-being, but then leading with the people side of sustainability, what we might call people-centered initiatives. I'm going to jump to the end of the story. I don't want to get too depressing, but my colleagues at ACEEE earlier this year put out a new report called The Long-Term Energy Efficiency Potential, What the Evidence Suggests. We thought that by looking at what we now know in the way of putting smart technology to work, smart behavior, we could reduce the nation's energy use 40 to 60% by the year 2050, all through various high cost-effective efficiency investments. And in so doing, that would lead to a net of about 2 million jobs, all the while we're saving our nation's homes and businesses about $400 billion a year. After we pay for the program costs, after we pay for the upfront investments, a net savings of about $400 billion a year, equivalent to about $2,600 per household if all those savings flow to the households. So it's a significant amount. It's a big opportunity, all brought about by this thing we call the long-term energy efficiency potential. Well, what does that then in turn suggest? The key insight, I might argue, is that instead of tiny increments of efficiency to design to say maybe a few percent here or there, the U.S. is going to actually be better off by thinking big about energy productivity and thinking big about energy services rather than relying on the usual set of costly and conventional energy resources. Here's an infographic I've designed to kind of highlight that point. A little hard to see here, but here's the idea of the 14% energy efficiency, suggesting that we operate more by waste than ingenuity in our economy, but that we have a very small representation of what the efficiency opportunity is when lurking below, taking out that 50% savings I suggested we might be able to have as a nation by the year 2050, as many as 250 billion barrels of oil efficiency equivalent. In other words, if we think about the heat equivalent in improved lighting fixtures, including building envelopes, improved industrial processes, automobile transportation, adding them all up in the heat equivalent, that would equal 250 billion barrels of oil efficiency. So a critical element in the behavioral side is to reestablish a new understanding of what it means to put energy to work in terms of the economic social well-being. So this critical observation, yes, I agree with Secretary Chu. In 2009, he said, science and technology can create much better choices, absolutely. But we suggest that we won't get there unless we bring people back into that process. More prosaically, Clay Shirky, NYU professor of telecommunications, said he was talking about the adoption of the internet, but I think it would equally be true with energy. A revolution doesn't happen when society adopts new tools. It happens when society adopts new behaviors. Again, information linked to new ways of encouraging smarter, more productive, more motivated behaviors. How important is behavior? People as a problem, or do we see people as a solution? I'm reminded here in one of our conferences, a summer study the ACEEE sponsors, 1993, somebody said, buildings would work perfectly well if it weren't for the people in them. And how you begin to ask that question really begins to do a lot to shape your solutions that you might bring to the task. How important is behavior? A number of studies, my colleague Lauren Lutzenheiser, 93, that same conference, a series of studies, nearly identical household dwellings, identical in space, geographic, weather conditions, the number of people in the buildings, have reported large variations, 200 to 300% variations in energy use for comparably situated buildings. Behavior matters a lot. It is an important element to what we bring to bear in maintaining quality homes. Non-LEED schools, I have one interesting data set here, have outperformed LEED buildings as a result of occupant behavior. Standard military housing units use less energy than upgraded units. Again, studies that are coming to the fore, suggesting that behavior can have a huge outcome. I'm going to explore just one of these with you here. The story of two schools in Colorado, the Rocky Mountain High School and the Fossil Ridge LEED High School. Now, interesting to note that both in 2005 started out with very comparable kilowatt hours per square foot. The LEED building moved its energy use down, saving perhaps about 10%, something like that. Well, maybe about 5% actually from 2005. The non-LEED building reduced by a substantial amount their energy use per square foot, building on behavior. We've got the study here, and we're going to actually update this particular study, but the story is the Rocky Mountain High School created a new culture of conservation through the work of charismatic leaders, people who got energized by the work they were doing and who imparted that enthusiasm and allowed people to imagine and their students to bring about new ways of thinking about what was going on in their schools, and by communicating their expectations and their successes. Enhanced sense of personal and group efficacy, their sense of well-being, what they as a group could do and what they could deliver in the way of savings based on knowledge of how their school was using energy now and what they could do if they began to think differently about things. And certainly, no question about it, by engaging the administrations, certainly the facilities manager, teachers, and the students all together, they achieved a higher level of savings than a LEED certified building did. Behavior matters. So how big is behavior? If we want to look at it from an energy and carbon savings estimates, Tom Dietz, a sociologist, together with others in 2009, he was focusing then on carbon dioxide emissions, and he took a look at 17 different household actions and suggested as an economy the U.S. could reduce emissions of carbon dioxide about 123 million metric tons a year, fairly significant. The potential residential sector savings about 20% as a result of behavior. The potential savings nationally about 7% because residential is only about 25% or so of the total. And that could be done, they suggested, over a period of 10 years. This is one study published in the Proceedings of the National Academy of Science. But then my own colleague, Karen Earhart, and I did in 2009 for the European Summer Study, Energy Efficiency Summer Study. We were focusing more on energy savings opportunities, and we took a look not at 17, but 100 household actions. We found a comparable level of savings, 22% in individual households as possible from a behavior related, about 9 quadrillion BTUs, about 9% of the nation's total energy use at that time. And we had, not 10 years, but a period about the 5 to 8 years, again, if given good information, incentives, motivation, and that type of thing, that as a possibility. That's a second study. And then a third one. And they're all seeming to conform and fall into this general category, about 20 to 30% savings in households in this case, brought about by behavioral changes. So Jerry Gardner and Paul Stern, both psychologists, in 2008, published in Environmental Magazine, suggested energy savings opportunity. They took a look at 27 household actions, again with potential residential sector savings of about 30%, or about 7% of the nation's overall energy use at that time. So we're beginning to see that just the behavioral, the shifting in lifestyle a bit, the change in habits, if you will, and the smarter decisions in what we might call low-cost, no-cost actions, somewhere in the 20 to 30% savings. I would argue that that's an important resource, but equally important is it lays a foundation of greater awareness that can move on to a larger scale savings as we move out to smarter design and upgrading our technologies over time. So it becomes a foundation on which we might be able to build. The critical issue is efficiency, making the invisible much more visible. Many people don't see the difference in lighting, how many kilowatt hours it might use to produce a set of lumens per watts. Many people don't understand how a car is using less gasoline to get the same distances. The problem, energy and energy efficiency more critically, has been a largely invisible technology. People haven't seen it. So while the imperative and the scale of the efficiency resource remains very large, I'm suggesting we begin first by exploring the possibility through feedback mechanisms. That begins to lay a new set of understandings, changing habits over time that we can build on more positively when we begin to expand the horizon of opportunities in the future. So how do we engage people? Well, the first example, as we've suggested and alluded to, information. Providing them with information about their energy consumption real time using technologies, certainly, but programs and priorities, and helping them understand the amount of savings achieved. So residential feedback, you've seen these different displays that they might see. Compared to the commercial scale feedback mechanisms, as I'll show you in a minute here. On the residential scale, we did a meta review suggesting a range of savings, 4 to 12% on average. We saw as much as 30% savings, as low as 1 or 2%, but the range about 4 to 12%. In commercial buildings, the Cisco Mediator, a very interesting technology. Many buildings have different protocols by which they communicate and maintain operation of lighting, of computers, of sensors of all sorts, of heating, of cooling. The mediator is a technology that not only informs the business manager about what's going on in that building, but allows different protocols to talk to each other. So you can optimize the use of a building simply by having now better feedback on the one hand and a system to help you say, aha, you can turn down the lighting, nobody's there, you can shift your air conditioning load, or you need to turn up air conditioning a little bit because you've got a little bit more in the way of computers on, what have you. But without changing the technology, Cisco, in the Google Mountain View campus, about a 20% savings. No change out of technology, just a better optimization through feedback and information. So the study that my colleague Karen Earhart and my colleague Kat Donnelly, who's at MIT, did in 2010, we did a meta review of 57 different feedback studies, and I've already alluded to. We found an average household electricity savings of 4 to 12%. This is all historical, done before we really got smart about what kind of feedback really could occur and before we learned how to do a better job of thinking about social sciences affecting our decision making. There are two kinds of feedback generally we talked about. Indirect feedback. This means feedback that you get largely after you've consumed, maybe 2 weeks or a month after. You maybe get a bill or some sort of information in the mail, say, here's how you did. Feedback after the actual consumption versus what we call direct feedback, meaning it's provided real time. As you're using it, you can make adjustments on the fly. We found 3 different mechanisms of indirect feedback that we cataloged among these 57 studies. The first is the enhanced billing. This is some of you familiar with the O-Power type technology. You get in the mail a month after you've used your electricity and you've gotten your bill, how you can begin adjusting. We found about 4% savings with what we call enhanced billing. Again, indirect feedback. But then as they move to the web, energy audits with ongoing and more frequency, 7% moving up to an 8% with daily, weekly feedback. Household-specific information included in things like advice on what you might be able to do given your unique household situation, your own usage patterns, and the like. Again, that's the indirect feedback. But then as we moved into what we call direct, real-time, as things are actually going on, real-time feedback At the premise level, meaning wholesale, whole building activity, 9% savings, teasing out to an average of 12% as we got the real-time information down to the appliance level, as the technology learns about your specific usage patterns, whether you're using lighting or hair dryers or swamp coolers or spas or what have you, information relating to your specific usage pattern on average of 12%. Now here's the kicker. Karen Earhart Martinez and I think that we could begin to imagine a 20 to 35% savings as we got smarter with feedback technologies and as we did a better job of really turning to the social sciences to see how it is that people do respond, how it is that they do hear information, what it is that motivates them to change their use, and then by accommodating with the kind of real-time information that makes sense with the right people in the right place, a much larger savings is potential. This is yet to be proved, but we think the evidence based on other things from the health community and other things going on there, that's a definite possibility. But then how can we engage people? And we need to start with the idea, are we talking about rational or predictably irrational people? Dan Ariely had a very interesting book out, Predictably Irrational. And we talk about Homo economicus, economic man, individuals think and choose unfailingly well, we assume, in most of our program designs, making, yes, very well-informed decisions, very thoughtful, rational ways of understanding how they might act in a particular situation. That's what most program designs are built to right now, is what we call this Homo economicus. But we want to think about Homo sapiens, real people. That is to say, individual behavior isn't always guided by conscious choices. And when it is, we're often predisposed to things like systematic biases in the way we think and act. Karen and I put out a paper suggesting that, yes, it may be economically irrational to do something, but it may be socially rational, very rational, because of your understanding, your peers, what you see, other choices that you make. And it's in this larger context that we need to begin thinking more about how we engage people, and they're certainly predictably irrational behavior. Now, Danny Kahneman won the Nobel Prize a couple years ago for his work bringing psychology into the realm of economics. This is his book, Thinking Fast and Slow, and he's suggesting there are basically two ways of thinking, two systems of thinking, the intuitive and the automatic. We sometimes call that the lizard brain, right? And then the reflective and irrational. So we might have in the lizard brain the uncontrolled versus the reflective and irrational, the controlled kind of response. We may have the effortless, the thing to do immediately that's so easy to do we don't even think about it, versus what we might think of as more purposeful effort. We might have associative versus deductive reasoning. We might have fast versus slow. We have unconscious versus self-aware, all of this. Now, we might call this the Homer Simpson approach to thinking, the lizard brain, if you will, versus the Spock approach to things. And the interesting point of most program designs, most building codes, most standards, we're focusing more of our efforts over on the one side, wholly ignoring the huge resource by coming to better terms with what it means to be predictably irrational, to understand that we do have biases, that we do perceive, and we pick up cues in many ways than just cost-effectiveness criterion. So how can we engage people? Well, here's an experiment. Households were given one of 4 door hangers. Remember, this is the old technology, door hangers. You were hung on your door, and you see this in hotels right now. This is building on the work of Bob Cialdini, a psychologist, social psychologist out of Arizona State University. The economic door hanger, hung on your door. You can save money by conserve energy. You can save up to $54 a month by using fans instead of air conditioning. That's the one approach. Another approach is the environment. You can protect the environment by conserving energy. You can prevent the release of 262 pounds of greenhouse gas emissions per month by using fans instead of air conditioning. The societal benefits. Do your part to conserve energy for future generations. You can reduce your monthly demand for electricity by 29% by using fans instead of air conditioning. The last door hanger, the norms. Join your neighbors in conserving energy. 77% of San Marcos residents often use fans instead of air conditioning. The winner? The social norms. households that had that, compared to the control group, reduced their electricity by about 10%. These other households on the average of maybe 3 to 5%. Again, how we motivate people, understanding what it is that triggers a response can have a very big difference in outcome. Of course, now the really smart social scientists among you would say, well, let's do a couple of these together. Let's figure out how to weave multiple messages, how to layer things on, how to build up a greater capability. It's sort of like the gaming industry. Well, you've done level 1, you ready to move on to level 2? That kind of thing. How we might engage and build up what psychologists and sociologists call self-efficacy, the sense that you can do things and that what you do matters to your household, to the environment, and to your local economy. So strategies to catalyze behavior. My colleague Karen Earhart's developed what she calls the time model, although as I reminded her, you rearrange the letters, it could be the emit model too. So we have to look at these things carefully. But the time model, targeting is the first step. The scale, people, and actions have to be targeted to the unique circumstances that you're trying to address. It cannot be a broad sweep, everything applies to everybody. And in a lot of sense, it gets back to sort of the state versus federal government in a lot of ways, but we need to focus on who it is we're trying to target, what level of income, what neighborhood do they live in, what part of the city do they live in, that type of thing, and really focus on what matters to them. And then informing. Consumers have one set of information they may desire. Producers may have another set. Sometimes consumers can be producers. We have policy makers and program managers all have different ways and they need to be informed, all different ways that they understand and process, and all different kinds of reactions they need to encourage or that they will follow. And then motivating with all of this using, as I've suggested, norms. 77% of the people do this. In hotel rooms, the towels, we found the most effective marketing is 77% of the people who have rented this room in the past have reused their towels. So understanding norms, networks, goals, and commitments. Again, the goals and commitments, if you make public your commitment, you're more likely to follow through than if you just make a commitment, oh yeah, sure, I'll do 10% type of thing. And then empowering. Dissolving the financial and structural barriers to provide, enable significantly better choices. Example of empowering. Here I'm drawing on the work of Thaler and Sunstein in a book they wrote called Nudge, a very interesting book. And we're talking about removing barriers and providing and enabling better choices. And the example I'm citing here is what we call choice architecture. How you frame the choices really can make a significant difference in outcome. Choice architecture is about creating a context in which people are likely to make better decisions simply because the choices have been framed differently. And it's a decision that they themselves will judge to be better off as a result. So we're not prescribing for them, we're giving them the chance to make the choice in ways they feel better for themselves, that they're better off. So we applied this, actually again my colleague Karen decided to test this out real time, what we call the Beck Low Carbon Lunch Experiment. This is in 2009. Beck is the Behavior, Energy, Climate Change Conference. It's just recently ended in Sacramento last month, and I'll talk about that in just a minute. Interesting outcome. So the 2009 Beck Low Carbon Lunch. Now, the standard ACEEE conference, we get people who register, they get 90 to 95% meat-based lunches. If they want their vegetarian fare, they can opt out for it. So we typically get 5 to 10% who go vegetarian. And in our Beck 2007 conference in Sacramento, we had pretty much that same. We had 83% meat-based meals. 17% of people opted out for vegetarian meals. We got the idea because the Beck conference came to D.C., we had more control over it than we did in Sacramento. We began working with the hotel. What would it take for you to serve 700 vegetarian meals? Most hotels think of vegetarian as a salad bar, right? And maybe grazing for a few bites here and there, nibbling. They actually took on the responsibility of learning how to cook for 700 people vegetarian dishes that tasted very good. And then we turned the registration around. Instead of having meat-based as the standard fare, we said, aha, vegetarian was the standard fare. You could have your meat, and so we reframed the choices. And we got 80% of the people that went vegetarian. Quite a difference by reframing the choices. The interesting thing is we got not a single complaint from anybody. You had your meat if you wanted it, and the meals were good because the hotels took the time to learn how to cook to that standard in ways they had not done before. And more often, they were intrigued to be part of an experiment. They were intrigued to be included, and they applauded when they realized they were being guinea pigs in this whole thing, the people. So the point being is that reframing, choice architecture, how we frame the problem, how we frame the choices that might logically flow can have a very significant difference in outcome. We know that meat production is responsible for 18% of the global greenhouse gas emissions, and that omnivores, for better and for worse, 7 times the greenhouse gas emissions than vegans. So there's not a big savings that's direct energy, but a very large indirect savings as a result of reframing the choices at hand. Again, bringing smarter social science to bear on energy decisions in very important ways. So perhaps our ultimate economic and energy efficiency resource. I'm recalling the comment of early 20th century UK essayist Lionel Strachey 100 years ago. I think it's still true today, wouldn't you guess? Americans guess because they're in too big a hurry to think. Remember the fast, slow we talked about? We have Jerry Hirschberg, who is founder and former CEO of Nissan Design, who noted creativity is not an escape from disciplined thinking, it's an escape with disciplined thinking. Or finally, my favorite actually is Henry Ford. He wrote a book in the 1920s, Thinking is the hardest work there is, which is the probable reason why so few people engage in it. Yeah, are we guilty of that? The key takeaways. The energy efficiency resource is much larger, and more necessary to develop than generally understood. It's not just a nice way to bring down a few greenhouse gas emissions and save money. It is critical to the larger well-being of our economy. Engaging, empowering, and motivating consumers is a critical first step in building large-scale savings. For a real, deep, and lasting change, we think requires a layered approach to changing behavior. That is to say, using multiple methods, multiple messages, means of reaching people in different ways, new ways, not only as individuals, but as family members, as neighbors, and as co-workers. In other words, multiple dimensions, layering it on over time, not just to test if it works, but to build up the capacity for a greater behavioral response. I haven't touched on it here, but I will add one other thing. It also requires a new utility business model, one that shifts from the sale of commodities we call kilowatt hours to providing value-added services and then helping energy providers pull revenue stream off of the value-added services rather than simply off the kilowatt hours of commodity sales, and to do so in ways that save ratepayers money and generate positive returns for investors. Or back to my colleague, the American philosopher Gary Larson, we've got a dog on a high wire act, and he's juggling a number of different things, and one looks to be a dead cat. I've never quite figured that out, that dead cat up there. The caption reads, "High above the hushed crowd, Rex tried to remain focused. Still, he couldn't shake one nagging thought. He was an old dog, and this was a new trick." Or more formally, Maynard Keynes, in the preface to his book, The General Theory, I think this holds. The difficulty lies not with the new ideas, but in escaping the old ones. And I've provided a few key references. I can provide the more complete for those who want to dig a little faster and deeper. And for more information, we have also our book that Karen and I co-authored. We co-edited, actually. The book, People-Centered Initiatives for Increasing Energy Savings, came out about 2 years ago. I do recommend that as a starting point if you want to dig a little bit more on that. And with that, happy to take some questions. Or comments, or observations. Yes?
So getting back to the very beginning, where 86% of the energy doesn't contribute to society. So you're familiar with the Lawrence Berkeley spaghetti graph?
I am indeed. That's Lawrence Livermore, actually, National Lab.
Okay, so that shows 45% gets delivered as energy services. So,
right.
So can you talk a little bit about what gets wasted from that point on?
Yeah, if you read the fine print on that, at the bottom, in very fine print, their assumption is that industry, homes, and commercial buildings are 80% efficient. Their graph depends on that.
Right.
They also depend that transportation is at least 25% efficient. When you begin to make adjustments in those, then you get down to my number, 14% of energy thrown at the economic problem is actually converted into work. Work meaning the transforming of matter into goods and services.
So are you taking into account things like, which I imagine the Livermore graph doesn't, driving that doesn't contribute to anything useful, or you make something that you end up throwing away, or wasted food?
Yeah, in fact, we could imagine things like, I'll give you one example. For every bite of food that we take, we waste about 6 bites of soil. That kind of thing has an enormous energy implication because we have to substitute productive soil for fertilizer, for example. Or lighting, the conventional lighting, and you guys may have better numbers, Kevin, than I, but I'll give you an example of how the level of inefficiency, just 2 numbers. If we assume that incandescent lighting is as much as 8% efficient, and there are some who think it's 4 or 5% efficient, but we'll use 8 just to throw out the number, and we know that our electric generating system is about 32% efficient, 8 times 32 is about 2.4% efficiency. In other words, all the light that we want, the lumens we want, 2%, 3%, 4% maybe is giving us what we need as a system, and the rest is all wasted. The other thing is, as a nation of electricity utility providers, we started off as a nation with about 2.5% efficiency in 1900. In other words, that's what we got, kilowatt hours for the amount of energy we put into those combustion turbines in those days. 1961, when I was a junior in high school, Ike was in office still. We moved up to about 32% efficiency. So we made a pretty marvelous increase. But we've hovered at 32% efficiency since Ike was in office. We are still at about, as a system, about 32% efficiency today. What we waste in this country in the generation of electricity, just the waste heat, is more than Japan requires to power its entire economy. It's huge. It's huge. So the issue is that if we want to motivate behavior, we need to have a new understanding of how energy is actually at work in the economy, and then reach out to people and engage them in ways that they can understand and that motivate them, whether through norms or through making public commitments or through their understanding of what it saves on their household energy bill. Waste is large. I'll give you another interesting example. It's hard for me. One of my favorites. We have in this country 272,000 traffic signal systems, and they do not operate at all at an optimum level. But imagine if we took and retrofitted all of them with sensors that could read traffic flows 2 or 3 blocks away. And then we allowed them to dynamically reprogram on the fly as they saw a change in pattern several blocks away, reading from the different directions. The National Transportation Operations Committee, a bunch of engineers, said that we could save 5 to 10% of our on-road gasoline consumption just by putting in smarter use of technologies. Why don't we? Well, behavior's at play. Because we're sort of stuck. It's comfortable to continue the old way of doing things. It requires less work, less thought, in the words of Henry Ford and others. So I think there's a lot more we have to play with, a lot more in the way of opportunities, but then how we make that richly available in ways that motivate people is the task at hand. But I stray. Yes, Jake?
Back when you were showing the graph of the different energy savings per type of residential energy management system, so there was relatively even steps. Do you know how the cost associated with those savings? I mean, did it follow kind of the same pattern of being more efficient to go up to the next level of energy savings and system, or is it more exponential than that?
It's less exponential than that. Bottom line, on average, depending how you make assumptions, we found that the feedback was on the order of about 3 cents a kilowatt hour cost. But that's only because we're still pretty kludgy at doing it. And we've got, so while O-Power does the billing, they'll mail out billings and they'll do the analysis, say, put a smiley face on the bill and say, you've saved 20% compared to your neighbor type thing. Whereas C3 Energy is now moving into real-time, online, portal-based, web-based interaction using, devices like cell phones and iPads to monitor real-time. Costs will start coming down. I'll give you an example of cost, how it's coming down. Anybody hear of the Raspberry Pi? Anybody know the Raspberry Pi? Interesting. It's a computer that's no bigger than a credit card. And it is every bit as powerful as my laptop today, and it costs $35. Costs are coming down. I've got a picture of it. It was developed by the University of Cambridge, interestingly. And this gets back to the behavioral element in a different way. We think of behavior as adopting. How do we motivate people to adopt? I'm thinking behavior, how to innovate. University of Cambridge said, You know, we're getting a lot of PhD graduate students in computer science who have never mucked with a computer. Not like we used to when I was back then, because it was cheap back then. You could afford to break it, and it didn't cost you very much. So you got and you experimented, you played, you reconnected wires, you rearranged things. And Cambridge said, we've got a lot of people who are going for PhDs who have never played with the guts of a computer. And so they asked people, could we design a computer where cost was no longer an issue? My colleagues at ARM is a UK firm you've probably never heard of. They are the counterpart to Intel. Whereas Intel, for example, builds chips, very powerful processors, and say to the equipment manufacturers, designed to our processor, it's got so much power you won't believe. ARM says, you've got a particular problem you want to solve. Tell us what you need. And then they farm out the design to maybe 15, 20 different software engineers, and they come up with a winning design that meets the needs of the equipment manufacturer. Then they go find a foundry to build that chip to that unique need. Now, ARM is interesting because 90% or more of all cell phones use their chip design. You've never heard of them, but they're very powerful in the business. ARM, together with University of Cambridge, came up with others, to be sure. It was a collaborative effort, what we now call the Raspberry Pi. $35 a computer. Yes, you still got to hook a video device to it or some sort of display, and yes, you got to have some sort of input device, but the computer itself, very interesting. So costs can come down, and that 3 cents a kilowatt hour we talked about could be down to 5 mils, half a cent a kilowatt hour over time, as we begin doing more and learning to pay attention to social science and what are the unique insights and how people behave, and in terms of when they behave, and what's their timing, what's their sequence, what are the order of information flows that matter to them, and what do they know they're doing relative to their community or to their neighbor or to people of similarly situated homes, what have you. Costs can come down. But right now, it's on the order of about 3 cents a kilowatt hour for feedback, more or less, but a lot cheaper. Yes, John?
How does politics figure into this thinking? Is it always a grassroots issue and it trickles up? Or?
Very good question. Politics matters. All politics are local, and to the extent that we begin to reimagine what it might mean for the well-being of our economy on the one hand, and for things like climate change. Talking to some people from the Department of Interior today who have an interesting task. They've got to solve for a multiple land use management of public lands, even as they're now saying to me, the lands are changing dramatically. Forest fires, dryness, drought, rain are beginning to shift dramatically, and how to manage in that kind of a world. Same thing with a community. We are out in the middle of developing what we call our energy stress test for communities. How well your community will thrive or not if you have a sudden disruption of energy supply. How well your community will thrive if you have unmet electricity demands or unmet power demands or gasoline needs. How your community will thrive if prices are volatile and if they affect the price of other things, or how your community will thrive if you have a slow, steady increase in the cost of energy. I think that energy stress test may be among the kind of things that help people think their being comfortable today may not be an indicator of their well-being tomorrow if they don't take a more active and open-ended thing. And then, yes, they've got to let the politicians understand. For the most part, there are some exceptions. One of the interesting books I've finished reading, perhaps some of you know Doris Kearns Goodwin. She's the one that wrote The Team of Rivals. She wrote also she's written several interesting books. One about Franklin Delano Roosevelt, No Ordinary Time, about World War II. It was very interesting to me. What won the war for us, I think, in World War II, not our materiel. Yes, we were able to do that, but because we came together as a nation. And we began to realize that we had to work collaboratively at a scale we've never affected before. And that came from the bottom up as much as anything else. So how communities can see the need and how empowered they feel to act and what information they have to act on, and then how they see their neighbors, their fellow businesses, whatever, doing things differently, that begins to filter up to the politicians. I think it's probably the way it's going to have to be.
How will you disseminate your stress test?
Do you get my images I'm communicating to you now? Good question. We're going to be going live with a website here in about the next 4 to 6 weeks with that kind of information. But basically working with some communities, we're now talking to the city of San Jose and Santa Clara County about conducting one of the first, and we're going to actually work in Calais, France, in that region to do a similar sort of thing. My colleague, some of you know the name Jeremy Rifkin at all? Rifkin, he's written about 18, 19 books. He's not very well known here in the States. He's seen as a sort of an illicit, what's the word, sort of like a psychic type, the negative impression of a person who speaks out on social issues. But his book, Third Industrial Revolution, How Lateral Power is Beginning to Transition the Economy in Unexpected Ways. He's exceedingly well known in Europe. I've been in Rome where he's spoken, and I just couldn't believe the number of people came to hear him speak, the mayor of Rome on down. People really resonate with him. He's got this message that we are now in the third industrial revolution. Whether we take advantage of it may be another matter or not, and whether we do may determine the well-being of our economy and our society. The first industrial revolution, Jeremy says, I think this is right, he says, all major revolutions occur when we have two things come together, a new form of communication and a new form of energy. So in 1750s, England particularly, we had the new form of energy was steam, basically. And the new form of communication was the printed word. That lasted, that carried us through. The innovations really allowed our economies to unfold, and they began to have a diminishing return until about 1900. The new form of communication was the telegraph and telephone, a little bit moving into radio. Basically, one-way or rigid two-way communication sorts of things. The new form of energy was electricity and the gasoline engine. And we're beginning to see diminishing returns set in on that. What he's suggesting is the third industrial revolution will be founded on new form of communication, the interactive web, and the new form of energy is distributed resources, being able to do things in ways that we've not imagined, taking advantage of things like the Raspberry Pi, for example. So we're beginning to test this in Calais. We've just signed a contract with them. Calais is an interesting region because they were a very heavily fossil region, fossil fuel based. They abut right up against Brussels. And they had a very dynamic economy that slumped, and they fell behind the rest of France. Now Calais is beginning to say, we want to leapfrog ahead. And they're taking on this idea of the third industrial revolution and the stress test, what it might mean for them. I think if we're successful, that may resonate with a number of people in some very powerful ways. So we're going to go live with the stress test idea in about 4 to 6 weeks on the web, and we're already beginning to conduct feedback to see how it resonates with people in ways they've not previously imagined. I hope we're successful. Yes?
Have you seen any good commercially available residential energy management systems that provide feedback for usage?
Well, I've seen more than my share, and more to the point, my colleague Beth Carlin, who's a social psychologist at UC Irvine with their technology lab, they have Caltech, California Information Technology Lab. She's inventoried 216 residential energy management systems, and you can contact her if you want to. Are you looking for your own personal use, or just as a research person?
Both.
Okay, well, I think folks here could probably give you some ideas what you can use locally here. In fact, weren't you telling me, Jake, about renting out some things? Do you have the ability to let people use in their own home some of these feedback technologies?
Not any full scale, like residential EMS systems that you'll hook up to your circuit breaker and interface with a software program and stuff like that. More kind of single point control systems,
okay,
but not any like comprehensive ones.
So
check out some of these resources.
yeah, so Beth does have an amazing, it's a full database catalog with these 216 different technologies, their cost and their performance, their scale, what they're designed to do, their functionality, that type of thing. She'd be a great resource to identify with that. Beth Carlin, Karlin. I can forward her email if you would like. So the problem is, in fact, we're now proposing there's so many of them. People get lost. I mean, that's part of the information problem, right? Which one do you choose? And that's part of the problem of the social science element of how to make it easy for people to understand that, yes, they are there, but you're not so swamped that you're frozen into inaction. So that's part of the problem at hand, how to make it easy for people to do things. Yeah, Kevin?
What were some of the differences between the more effective programs, the 57 different studies that you ran and that you studied and that you examined in 2010, up on the higher end of the 20 to 30% savings range? What were they doing different? Are they full-scale utility programs? Are they pilot programs?
Yeah, good question. First of all, the 57, we did 61 studies of 57 programs, and we broke them into what we call the energy crisis era, meaning up from 73 to about 1994, 1995, and then we had what we call the climate crisis era. Our results are based on the post-1995, about 32 of the 57 studies, just to let you know that. But the indicators of those that were getting the bigger results were, as you can imagine, real-time feedback and norms. And we saw this in competitions in particularly, in dormitories and neighborhoods where people understood, aha, you're using this and your neighbor or the next dorm or your community or whatever is doing this. And then public commitments, making public that, you ready to go for 15%? Yes, by golly, that type of thing. So those are among the critical elements. If you want to go much beyond that, you have to talk to Karen about some of the details of the specific studies. But we also had the campaign that the likes of IBM and I think San Diego Gas and Electric and Centerpoint Energy and Landis & Gear and others collaborated on the biggest energy saver campaign they conducted last year. Fairly interesting program. They achieved an average of about 8% savings of all participants on average, but the top 10% hit 25% savings. Now, as a social scientist, I'd want to know, what was it that those people did that the average was not doing, and learn and how to redesign that program to really understand that dynamic. Now, some of the things that are interesting, people were so excited about winning, they went out and did beyond the average because they wanted to win, or they wanted to be part of that top decile, if you will. So how do we learn from those kinds of experiences to pull up the average to the higher 10% kind of thing? Yes?
And on that same social norms kind of motivator, is it motivated, are people motivated by not being left out, or by being left out and not being part of a core group of their peers or whatever, or is it guilt? Or can you talk a little bit about that? What's that, the motivating factor behind social norms?
There's more to be teased out. First of all, this assumes we're not from Texas. Therefore, if you are using the most, you'll be the most proud, right? With no offense to Texans. My sister was born there, so I speak a little bit of that. But that said, it seemed like there were two things that were affecting that kind of behavior. Number one is awareness that other people were doing something. It wasn't just you, all right? So that sense that, well, my golly, there are things that people can do. So that was one. But the other element was, wait a minute, if he's doing it, why can't I? That type of thing. And I don't know that they've studied things like sort of the keeping up with the Joneses sort of thing, whether you're doing it because, by golly, if you want to be seen as cool, you got to do it too. I don't know if it gets to that level or not, but basically those two things. Awareness that something could be done and that my neighbor or somebody like me was doing it. Whoa, what could I be doing too?
So it's just triggering that point of actually thinking about it and that it's possible.
Right.
That's the biggest piece.
And we kind of I've got a neighbor of mine who is a physical fitness instructor. She knows a lot about energy of the body, But the minute I start talking about BTUs instead of calories, she gets lost. She's very smart, and she's got an advanced degree in psychology. She's a physical fitness instructor, talking with people all the time. But she gets lost in my jargon. I have to take a real step back to explain. And if she's not impatient, then maybe we'll have an interesting discussion. But if on one of those days she's real impatient with me, then there goes that discussion, right? Same thing about energy. How many people know what a BTU is, for example? All right, you probably know the technical definition. Do you know what the social definition is? What's that?
The match.
The match, right, the wooden kitchen match. 1 BTU is a wooden kitchen match burned down to your finger, roughly. All right, when we start thinking, you know how many wooden kitchen matches in a gallon gasoline equivalent? 125,000 wooden kitchen matches. And we may burn 12 to 15,000 of them to get us to move ahead. We're wasting all the rest of them. So that resonates with some people. Some people resonate with the idea of waste. You're wasting 86% of what you do. All right, that type of thing, as opposed to focusing on efficiency. You know, so what is it that you can make them aware? We are energy illiterate as an economy. That's the invisibility problem I talked about. So we have to figure out both in terms of how it affects our individual use, but then the larger well-being economy. We understand pretty much things like investment. We know notionally we got to make some investment to, you know, build up an economy. We understand things like, jobs, but we have a very poor understanding of how energy is at play in our economy. So both at the household and individual business level and at the macro level. Same time, I talked to a businessman out of California, a small businessman. He's got a small shop, 6-7 people. He helps other businesses promote their various wares, their products and things like that. He's cut his energy use by something like 50%, but not because he was focusing on energy bill savings, but because he was focusing on other amenities. He was able to reduce the amount of paper stock he was using in printers, reduce toner, reduce water, reduce the need for driving, so they only have one vehicle instead of two now as a company car. But it wasn't to save on energy, because energy is a very small, even though it's a very big part of what drives the economy, it's only about 4% of our nation's overall economic output, very small in cost, relative share. And the irony is that it is so critical to our well-being. The inefficient use creates other costs that ramify and constrain the economy. How many people would understand that? Because we haven't been doing a good job of tracking that as part of our national economic accounts. So at all levels, we just are energy illiterate. Yeah, over here, and we'll go back to you.
So, would you say that the most motivating, in your opinion, what motivates people more? Fear-based, like you're not doing good enough, or validation-based, like you're exceeding expectations? Do you find that people are motivated to respond?
I don't have a good answer for that, but as you asked the question, it occurs to me, you know that old notion, nothing ventured, nothing gained? Most people we all operate more like nothing ventured, nothing lost. We're more interested in keeping what we are already familiar with and what we understand and are comfortable with than we're necessarily to try something new, unless I get a friend to do it with me, unless there's another outcome that I might not imagine, unless I'm intrigued. So I think it's that kind of intrigue rather than necessarily loss. Although counter to that is this idea of the stress test, because that really is anchored to some very possibly unpositive, negative outcomes if we don't do things differently. But that has to be coupled with a real sense of opportunity and that I'm doing it with others. I'm not in it alone. So a combination of fascination and intrigue, but always with somebody else. We are a very social critter, are we not? And that means we've got to have others join the fray and be part of it and with us and share the experience, but then understanding that there is something we can do. So it's more in that kind of element. Beyond that, you're going to have to talk to real anthropologists or sociologists. Yeah.
I was just going to ask, you mentioned there was a Beck conference and you said there was a cool outcome that came out of it. I was going to ask you to talk about that.
There was a what outcome?
I thought you said there was a neat outcome that came out of the Beck conference.
That was the Beck low carbon diet that I put up there.
Okay.
That was the 2009 experiment where we just, the neat outcome in my opinion was that we just changed the registration form so that you when you registered, you got your meals were vegetarian unless you opted for meat, as opposed to the usual default. And we set that up as an experiment just to highlight the point. Framing the issue can have a very powerful impact on the outcome, how we frame and how we set up the choices. Yes?
You said that our current era of energy is distributed generation. Could you?
The emerging era for what we call the third industrial revolution, right?
Could you talk a little bit about what you see as the development of that? The social side or just in general barriers?
So I'm going to defer to Jeremy's description. He used to call them the 4 pillars. He now calls it the 5 pillars, all with a foundation of efficiency writ large. So if you can imagine a foundation of efficiency, then pillars to raise up the economy. First pillar is buildings or I would say structures. He calls them buildings. I say structures as positive power plants. In other words, we integrate the use of PV wind. I was just talking about Smith Gill Architecture earlier today, a Chicago firm out of Chicago. They're now beginning to look at buildings in an interesting way. They're beginning to design buildings so they need less material structural support because they're imagining winds moving up through the corners of the building, up through the building, so the building moves with the wind systems, that it's more dynamic. It sways a little bit more than you might imagine, but because it is dynamic, it doesn't need as much steel and structural support. Therefore, it has less mass, but every bit as productive. But as the wind moves up those columns, then they create wind turbines that generate power as the winds move up through the building. Things like that. I do not know if it's practical. I do know that we'll create what's a possible brainstorm into a brain drizzle if we dismiss it offhand. All right, it's that kind of thing. That's just one example. But I'd also say, obviously, things like distributed PV systems, for example, the costs are coming down so dramatically. And when we begin to imagine the alternative, all right, so we think about public infrastructure as things like the Cooley Dam. Those are public dollars invested. If we reframe the issue as my choice as a building owner or as a commercial manager of real estate, real property, whether I'm a C.B. Richard Ellis or someone like that at Cushman & Wakefield, that what I do has a palpable impact on the nation's infrastructure, demands for water and for energy. Why not invest in them as a public infrastructure? As opposed to calling a subsidy, we think about it as public infrastructure. In that case, we begin seeing that the multiple benefits flowing from, say, a large commercial building as having PV power as part of its operation, as being a power plant. And then the building on top of that, we know that studies suggest we can cut energy use 50 to 80% in buildings. So we reduce the demand for energy. You need fewer units of, say, PV, photovoltaic, sunlight systems on the home type thing. Then you have a public power plant. Or you have the possibility, my colleague, I don't know if some of you know Dan Cameron from the University of California, he runs the Renewable Energy Lab there. When I was at EPA, funded some work. Fuel cells, cars. You go to work in your car, you plug your car in, the fuel cell continues to work, you're shipping power back to the grid. While you're sitting at work, if you have to drive, I wouldn't recommend it, but if you have to drive, you're earning money while your fuel cell in your vehicle is grinding out power for the grid. Or industrial facilities, things we call combined heat and power, but other distributed systems in industrial operations, where you're siphoning off the waste heat and using it for other purposes in ways that you might not have imagined. There's a firm called Recycled Energy Development out of Chicago that specializes in how to take waste heat and convert it into useful electricity on the site itself. So examples like that. So structures, infrastructure as positive power plants. And then he moves into renewables. This is his second pillar. His third pillar is storage. Right now with capacitors and batteries, potentially at some point with compressed air storage, but then potentially into perhaps hydrogen as it's a longer down the road, but a possibility. And his fourth pillar is smart grid. But I prefer to think of it, and then he talks about smart transportation systems as well, along the lines I gave you with dynamic optimization of our lighting systems to induce a flow without stop and start driving, things like that. Those are his 5 pillars. The interesting element, and I'm talking to a firm, Burns & McDonnell. Burns & Mac is an engineering firm. I don't know if some of you know. They specialize in municipal utility, municipal operations, 5,000 person firm, interesting firm. They're employee-owned, which makes them very interesting to me because they are more dynamic than a lot of firms I've seen. They take a little bit more way of risk. How we might imagine, we're at a point where we can't do it serially, one thing at a time, one thing at a time, one thing at a time. We have to be bringing in elements of storage with on-site generation, with smart efficiency improvements together. But that means we have to address the community at the scale of its infrastructure, its built environment. and how we began taking that built environment and moving. Now, why they're interested in that is because engineers usually bid on, say, a municipal operation that might be what we call a one-off project. I'll fix this building for you, or I'll build this new bridge for you, and you're done. As opposed to a systematic rebuilding of a region's economy, where you have this contract in place. It's designed to enable a couple of different things to happen, but equally important is as it's done, then it allows the next thing to happen, and you begin creating a dynamic redevelopment of your built environment over time. It's that kind of thing that has to happen. Does that make sense? Yes, over here.
You showed the studies where you're estimating, the savings through behavior.
Yes.
And they each focused on a various amount of home behavior changes. And I was wondering what the commonalities were, how they selected the behaviors that they focused on. I think yours had 100.
Yes, the one that I did. In fact, the ones that we did, Karen and I did, actually included not only home use, but personal control of transportation as well. So we added probably about 25 to our 100, but it included everything from things like if you move your refrigerator an inch away from confined space so it can breathe, the compressor doesn't have to work as hard. It may save a couple of kilowatt hours a year just on that part. All right. Obviously, things like compact fluorescence and the low-cost, no-cost things, or the weatherization from ducts to water heaters, what have you. Just a whole list of things like that.
Did you put those in any kind of a hierarchy? I mean, was there any learnings based on the savings projections?
No, we did not. My intent in having that done was to behavioral programs for a long time have been thought of as niche strategies. Oh, maybe we could sell a few more widgets if we would adapt our marketing in this way. And what we were trying to do is suggest that there was heft to the behavioral resource. So we generated a model I developed that ran a bunch of Monte Carlo simulations. If you know, we allowed like 10,000 simulations of different possibilities, including things like interaction of technologies. If you're using less light, then you might save on air conditioning, stuff like that. But we just wanted to create the sense that it was bigger than we imagined. And if you thought that behavior was nothing more than habit, you change some habits, you might save 5 or 6 or 7, 8%. If you thought behavior was habit plus a change in lifestyle, you may start growing some of your own food, or maybe what we used to do, and I still do some, hanging clothes out to dry, stuff like that, lifestyle changes. If you thought behavior was habit and lifestyle changes, but also included smarter, what we call energy stock taking, things that you could do like replacing lamps or whatever, low cost, no cost sorts of things. And then ultimately, it's all behavior. I mean, your choices affect if you're even buying, a $3,000 HVAC system or something like that. That's behavior. But we were just trying to establish that behavior was bigger than just a niche strategy that might sell a few more widgets, basically. And that's as far as we took it. But your question's an important one. There's a psychologist from Canada, Doug McKenzie Moore, who specializes in community-based social marketing. His argument is, and I'm sympathetic to it, it's not that you save big initially, but you do things that create a sense of what, I hate the term, I really do, self-efficacy. But what that means, again, is the sense that you can do something and that what you do has an impact and a belief that you can do something. So his argument is you start at a community level with small things that enable people to have small victories. And then you, again, remember I mentioned the idea of layering. It's not just a one-off event. It is a building of multiple means of connectedness, information, interaction that build on one another over time. So you're building up that sense of self-efficacy. So it doesn't really matter that you're starting with maybe a 2% savings. It matters that you're getting people to move off the dime and you're giving them a sense of empowerment, a sense of accomplishment. Again, like the gaming industry, you achieve level 1, ready to go on to level 2, level 3 type thing. Yes?
What types of opportunities, within just behavioral changes or residential energy management systems does time of use charging bring to the table? Something that we don't have here in Idaho, but come down apply those services in the future. So I was wondering if you have any experience with what types of opportunities those provide.
Yeah, I would not be an economist if I didn't admit that prices matter. And so we do have in our study those that were conducted with regard to both, critical peak path pricing or time of use pricing, that type of thing. We have a number of studies that did with and without. We found a little bit better savings when you, again, the message is multiple connections. Yes, pricing dynamic, but together with information, and information not only about what you're using, but what you can do that matches you. What a low-income family can do is a lot different than what a middle-income or a high-income household can do. So if you send messages for a high-income household to a low-income, they're going to throw up their hands. But if you give them tips on what they can do, and then we get into indirect things, everything from composting to recycling, huge implications. Water conservation has a huge impact on energy, and energy has a huge impact on water type thing. So it really matters to the moment, the circumstance of the household or the business environment, whatever it may be. But price matters, although it's not all that matters. If you strengthen the power of the social norms, really what you're doing is you need less of a price signal to get that response. So from an economist's perspective, we may say that from an electricity standpoint, we may have a price elasticity of, say, minus 0.2. That means 10% price increase in electricity, you'll save 2% of your electricity bill. That's given existing norms, existing knowledge, existing motivation, existing knowledge of what's going on, what's possible. But making all that possible, I could imagine the elasticity being 0.4, negative 0.4. So a 10% price increase means you're now getting 4% savings. So they have to operate in a complementary way. That way, we're not using price as a form of punishment. If all you're going to do is raise the price and expect people to change, it becomes a form of punishment. But if you use price as a complement that becomes information, along with the other information that you can provide or people see that are available to them and that can operate real time, then it becomes really what it's intended to do, which is price as information. So it's got to be a complement. Yeah, Kevin?
Along this lines, are there particular utilities that you think are doing a good job, or even for full deliver programs or for the pilot programs that we could look to as examples?
Well, I'd have to say, I think some of the California utilities are obviously doing a pretty good job. It may not be so obvious, but with their decoupling, and they have an incentive, and they have a very strong form of goals there that are publicly ones that have to be reached. They know they have to perform that. When I've got a couple of utility guys on my board of directors, and the one thing they preach, and rightly so, is the certainty of the program. They've finally been given the financial wherewithal. They can earn a return on their efficiency investments just as they can on their normal plant. But it's also expected because it's a stated goal that's certain. It's not going to go away. They can plan to it, and they have fewer surprises down the road kind of thing. But then there's the Vermont Energy Investment Corporation are doing some interesting things. They're more of a, not a utility in the usual sense, but in the sense of a community-based enterprise that's promoting the smart development of energy. My own state, Arizona, has an interesting program. We have a goal, energy efficiency resource standard, that suggests we will get to 20% below 2005 levels of electricity use by 2020. That's fairly significant. Now, the bad news is, being Arizona, all the Democrats lost. We have all Republicans coming into office, and they don't like this efficiency stuff. So we'll see how well that hangs in there and what kind of a backlash there may be. But yeah, if you go look in our state website, we have we do our scorecard every year, but as part of that, we also describe all the different programs the utilities are running, and we've got a couple of interesting reports out on the scale of utility programs that are very successful and lessons learned kind of thing. It's not my specialty, so I can talk to you about high-tech world not as well as I can about utilities, however.
I wanted to follow up with persistence. I mean, I can imagine some of the strategies, competitions, for example, might be short-lived. Maybe not, I don't know if do you have any data about the persistence with regard to the various strategies? Or
Yes.
recommendations?
In our meta review, we did tackle persistence. And no surprise, where the feedback was persistent, the savings tend to be persistent. A degradation, to be sure. But then what we also saw, the longer lived programs, you saw a building up of capacity and people sticking with it and learning. But yeah, that's exactly the point. The studies that we ran, I think the longest of the 57 was maybe on the order of 2 years, but most of them were like 3 months, 6 months. So they were designed to test the idea, not intended to be a major delivery of services to the residential sector. And that's an entirely different perspective, basically. And it was designed to be tested as a pilot, not designed to be run as an ongoing, legitimate resource.
So are there other studies testing it to be an ongoing legitimate resource?
I didn't catch that first part of your
I
question.
said, are there other studies being conducted to determine whether it's an ongoing legitimate resource?
Well, in fact, we just did a paper with C3 Energy that's going to be released probably in a month or so. They're one of the Opower-like firms, but they use they're getting right now about 6% savings, whereas Opower is getting about 2% savings. Although Opower is starting to pick up their feet a lot, which I'm happy to report. Both are colleagues or allies of ACEEE, so I can't say which is better necessarily. But C3 Energy is at a conundrum because most of the program evaluations that are being conducted are what we call technology installation programs. I've got this many widgets times this kind of kilowatt hours times this times that, and I got a savings. Whereas behavioral, we need to focus on the energy bill, the bottom line. And whereas if I get a rebate for $25, I'm going to be thinking more along those lines, and I'm going to ignore everything else. But if I'm working with customers to help reduce their bill, and I give them multiple choices, and the focus is always on reducing the bill, not on installing widgets, then we're likely to see a much more possible outcome. And that's why I think C3 Energy is getting more like 6% savings now, because they're focusing on constantly the bottom line as opposed to an improved air conditioning system or lighting improvement. And the other thing is that most of the programs in this country are built on lighting, residential programs. I think the statistic it came up with in this paper will release something like 3/4 of all electricity savings on DSM programs, demand-side management programs, are lighting-based. But we have new standards in place. And I think the utilities are going to be thinking about how to be a bit more ahead of the curve. And that's where I think you're going to see some really interesting generations. ACEEE runs a thing called the Energy Efficiency as a Resource Conference every other year. And I think next year it's coming up. It's designed to help think about how utilities might manage their 2-year plans ahead and what new technologies, what new programs, what new behaviors, what new incentives, what new financial business models might be brought to bear that would make it in everybody's interest for them to move ahead. So we'll see. How are we doing?
Maybe a couple more questions. I have just one more. I'm curious about where the source of education comes from, for the homeowner or the occupant that's the most effective. So like them hearing about programs or techniques from the utilities is one source, maybe from TV is another source, or even from the builder that they buy their homes from. Are you aware of any research that analyzes the source of information where it comes from as a method of being more or less effective?
No, that's the bad news. I know there are suggestions of what drives particular results in that regard, but there hasn't been a really solid look. In fact, that's one of the things that Beth Carlin and I and some other people want to put together is to really, we've got right now, it's no longer 57 programs. Our study was seen as a major step forward in this thinking, and now there are like over 300. Everybody wants to do a pilot. But we've got to move out of the pilot stage and move more into what my colleague Michael Sullivan calls experimental design. That we, yes, absolutely want to achieve a higher level of performance and then learn as we go, not to test the idea, but to test the deliverability. And there hasn't been any work done like that to know. But we also know that incentives do work, incentives with prices. In San Jose, there's a firm called Wattzon, Wattzon, that are helping the city of San Jose run a home energy feedback program, and they're melding it with coupons, so that if you achieve a certain level of savings, you get a coupon from your local merchant that will entitle if you achieve this level of savings, and the coupons are deep discounted. You may get, pay 30 cents on the dollar to get $1 worth of goods. Now, the interesting thing is that's elevated the credibility in the minds of the homeowner or the renter, either one, the legitimacy of this program. They can get coupons. Interestingly, and of course the merchants love it because it gives them advertising, right? Interestingly, the amount of recovery of those coupons is single digit. In other words, the coupons enhance the credibility of the program, but there's very little actual payout because people are too busy to go cash in the coupons, right? Or take advantage of that, or they're at the right place at the right time. They happen to have a coupon in hand, or they got to print it out, or who knows what it may be. But that's another. So it's melding of information, incentives beyond price, and it's kind of like a price actually, negative price. So I don't know. It's a very important piece of work. It would make if it didn't need to happen fast, I'd say it'd make a damn good PhD dissertation. Yes.
Can you speak a little bit of the foundation of cost effectiveness? Because when you look at our existing system,
Yes.
behavior-based programs, we really don't have cost effectiveness. It doesn't pass TRC value, UCT. Where, in your studies, can you just kind of elaborate on that?
I can kind of elaborate, yes. Do you want me just kind of, or you want me to actually elaborate? Good question. In our study, I do have a chapter on cost effectiveness, and we take a look at that meta review. You can download that, take a look at what we do there. But we have cost effectiveness for example, for the enhanced billing. We took a look at O-Power and other data and what they were actually spending to deliver, say, the bill stuffers, what that cost and what the savings looked like. And then for other technologies that were dependent more on feedback, real-time feedback kind of thing, we took a look. That's where I got my colleague Beth Carlin involved, where she did the review of all these different technologies that could be made available at what cost, and made assumptions about whether the utility paid for it or whether the household did, that type of thing. And we got a new report out that Google asked us to do. The bad news is I was a year late in delivering it, so Google wasn't very happy, but some interesting results came out. So we can elaborate. Yeah, the TRC, we did use TRC, and we did think about program administrative costs. We did think about incentives, and then we thought about whatever else the customer might have to spend as well. So those are basically the three-layer of costs. And then what the benefits were essentially kind of a combination of wholesale versus retail discussion of avoided electricity costs. And then we looked at those over time as part of our simulations. So we allowed the simulations to both iterate on responsiveness, on number of households that participated, on amount of efficiency gained per household, and then we allowed cost to iterate as well. We came up with well over 2 on average as a scenario. That is to say, because we're looking at the nationwide economy, residential electricity users. And we said, well, if we have opt-in versus opt-out, if we have program A, B, C, or D on various bases, that type of thing, and then how many households would participate. So we took a pretty good in-depth look. It's not that more couldn't be done, but we generally found pretty conservatively about a 2-to-1 or better of cost effectiveness of behavior-based programs. Then we took another scenario where we said, this idea of the enhanced capacity, sort of a fifth scenario where we said, as people learn, and they may have a hot water heater that goes bankrupt on them, and they got to replace a hot water heater. Under their old regime, they might replace it with an 84% or 86%, but under the new, they might go 92% efficiency type thing. So we introduced the idea that the immediate response was not just behavior, but a learning and increased capacity for them to act as they either retrofitted or had to replace existing equipment or whatever like that. So you can look at that if you want to, our Google study, take a look at that. And then, we did the appropriate discounting, that type of thing, discounting future dollars back. So we did discounted TRC value.
Did you include non-energy benefits into that equation?
I'm sorry?
Did you try to include non-energy benefits into the?
We did not. Yeah, by non-energy benefits, you mean, for example, things like healthcare costs because of reduced pollution. I've done a study like that for the great state of Nebraska recently where we did incorporate that, but that was a broader combination of technology behavior statewide as opposed to just focusing on behavior. But we used EPA's COBRA model. Are you familiar with that at all? COBRA is the co-benefits risk assessment model. What's interesting about it, anybody can learn to use it. If I can learn to use it, anybody can learn to use it. It has every single county in the country in the database. You can use either 2010 or 2015 data sets. And you can say, we want to achieve this kind of reduction in industrial fuels, but also power plants. We want to reduce average use of electricity. We want to reduce coal-fired generation specifically. And then it allows you to see what the actual reduction emissions are, and then how those emissions translate into healthcare costs, whether avoided chronic illnesses or premature heart attacks or visits to emergency rooms or reduced activity levels, things like that. They've got quite a few different areas. It's fairly surprising. So in Nebraska, we found that there was on the order of about a $700 million co-benefit with a combination of wind and efficiency penetration for that state. The interesting part of it, Nebraska had a benefit of $125 million, and the rest of the country benefited from Nebraska's reducing emissions from their coal-fired generation, that type of thing. But similarly, is Nebraska affected by what comes elsewhere from Iowa and Ohio, for example, too?
All right, thanks.
Oh, good questions, thank you.
A couple quick announcements. Thank you for giving us part of your evening to come and listen to this very premium information. Thank you for the discussion. It was good, 40 minutes of good questions. No one always gets that amount of time for questions. I was glad to see that the discussion was very lively and beneficial. Two quick announcements. Remember our next and last series for the fall series is Thursday with our last commercial session. So if you can make it, come on back. And then also Friday we've got a workshop, interactive workshop where we'll be showing people how to use some of the spreadsheet calculators we've developed, calculating energy and load savings on looking at things like earth tubes and passive solar and balance point calculations. So it's free. It's 8:30 to 12, so it's kind of large time commitments. We'll have free coffee and snacks, and we'll get a workshop on how to use some of these tools that we've developed. We've got some flyers on the corner of the desk over there. If you're interested, also you can check out our website or our Facebook page. Please sign in if you haven't done so. And also please fill out your evaluations so we can get those to Power, to our speaker, and hopefully improve our programs and continue to get stuff like this funded. Last thing, I'm going to talk with Skip and get some of those resources that he talked about. The Beth Carlin resource, the Google paper. We'll put those up on our website so people can link to those. It's all consolidated in one space. Also, we'll put them on our Facebook page. So if you're following us, you should check that out. If you're not, go ahead and like our page and get these updates, and we'll put those links directly on that. So thanks everybody for coming.